Rotating equipment, pumps, compressors, and turbines expanders, chapters 2 and 9. Topics, fundamentals. Starting relationships, thermodynamic relationships, Bernoulli's equation, simplifications, pumps, constant density compression, compressors, reversible ideal gas compression, use of pH and T's diagrams, multistaging, efficiencies, adiabatic isentropic versus mechanical, polytropic, updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu, equipment, pumps, centrifugal pumps, reciprocating pumps, gear pumps, compressors, centrifugal compressors, reciprocating compressors, screw compressors, axial compressors, turbines and expanders, expanders for NGL recovery, gas turbines for power production. Oh, what is heat rate? 2. Fundamentals, updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. Review of thermodynamic principles. First law of thermodynamics: energy is conserved. Change in systems: energy equals rate of heat added rate of work performed, EQW. Major energy contributions: kinetic energy related to velocity of system, potential energy related to position in a field, for example, gravity, internal energy related to systems, temperature, O. Internal energy, U. Convenient for systems at constant volume and batch systems, U2G, EU2GGH, Cc, O. Enthalpy, H equals U plus PV, convenient for systems at constant pressure and flowing systems, U2G, A2GGH, Cc. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. 4. Review of thermodynamic principles. Second law of thermodynamics. In a cyclic process, entropy will either stay the same, reversible process, or will increase. Relationship between work and heat: all work can be converted to heat, but not all heat can be converted to work. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. 5. T equals 0, P equals 0, V equals 0, H equals 0, Q equals 0, S equals 0. Constant temperature, constant pressure, constant volume, constant enthalpy, no heat transferred, no increase in entropy, isothermal, isobaric, isochoric, isenthalpic, adiabatic, isentropic, ideal, reversible, common paths for heat and work. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. 6. First law for steady state flow. Equation 1.19 R, HU for flowing systems, U2G, H2GGZQWCC, for adiabatic, steady state, ideal reversible flow using Ws as positive value, U2G, WHZ, S, 2GCGC, P, 22, UG, VDP2GGZ, PCC, 1, 22, PPDP, WVDP, S, PP, 11. The work required is inversely proportional to the mass density. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. 7. Thermodynamics of compression. Work depends on path. Commonly assume adiabatic or polytropic compression. Calculations done with pH diagram for H, P, 2, WVDPH, S, P, 1. Evaluate integral using equation of state. Simplest gas EOS is the ideal gas law. Simplest liquid EOS is to assume incompressible, that is, constant density with respect to pressure. 22. PDP1 PPP, WDP21, S, PP, 11. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at Minds.edu. 8. Liquid versus vapor compression. Can compress liquids with little temperature change. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu, GPSA Data Book, 13th ed. 9. H for gas compression much larger than for liquid pumping. Mechanical energy balance. Differential form of Bernoulli's equation for fluid flow energy per unit mass. Do 2. dP2GdZdWsGdHf0 frictional loss term is positive. Work term for energy out of fluid negative for pump or compressor. If density is constant, then the integral is straightforward. Pumps. U2. P. Circumflex. 2GZWSGHf0. If density is not constant, then you need a pathway for the pressure density relationship. Compressors. U2. 2. PdP. 2GZWGH0. SF. P. 1. Updated. February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 10. Pump equations. Pumping requirement expressed in terms of power, that is, energy per unit time hydraulic horsepower power delivered to the fluid, over entire system. U2PWMWVGZGHHHPS2F. VPVGZVGHVU21F2, just across the pump, in terms of pressure differential or head, WVP or WVGH, HHP, brake horsepower power delivered to the pump itself, HHP, WW, BHP, pump, updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 11. Pump equations for specific U.S. customary units. U.S. customary units usually used are GPM, SI, and HP. In 231 gallons gal lb, FWHP, HHP, min in 2 sec in 60 12 550 minutes FT1 galb to 1714 min in, FTLB sec FHP. Also use the head equation usually using GPM, FT, specific gravity, and HP, 8.33719 lbm FT 32.174, gal sec 2 WHP min FT sec FTLB sec LB FT hippo M 6550 F 32.174 pounds sec 2 minutes HPF, 1 galft, 3958 minutes. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 12. Static head terms. Fundamentals of natural gas processing. 2nd ed. Kidney, Parrish, and McCartney. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 13. Pump example. Liquid propane at its bubble point is to be pumped from a reflux drum to a depropanizer. Pressures, elevations, and piping system losses as shown are shown in the diagram. Max flow rate 360 GPM. Propane specific gravity 0.485 at pumping temperature 100 of. Pump nozzles elevations are 0 and velocity head at nozzles negligible. What is the pressure differential across the pump? What is the differential head? What is the hydraulic power? GPSA Data Book, 13th ed. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 14. Pump example. Pressure drop from reflux drum to pump inlet. PG piping C. 0. 48562. 366520. 0.50.2 144 3.5 psi. P203.5 psi. Inlet. Pressure drop from pump outlet to depropanizer. PGZP. G piping. C. P. Outlet. 0. 48562. 366574. 3.02.01.2 13.01.09.0 44.7 psi. 264.7 psi. Updated, February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at mines.edu. 15. Pump example. Pump pressure differential. PPP pump. Outlet inlet 264.7 203.5 61.2 psi. Pump differential head. HGC pump. Pump. G. 144 61.2291 feet 0. 48562. 3665. Hydraulic power. W 360 GPM 61.2 C 12.85 HP. HHP. 1714. Updated. February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at minds.edu, or W360 GPM 0.485291 FT 12.84 HP HHP 3958, 16. pH diagrams. Ref. GPSA Data Book, 13th ed. Updated. February 6, 2018. Copyright 2017 John Jetcherer, J. Jetcherer, at minds.edu, 17.